All right, L.3 is about algebraic limits. So how do you find the limits algebraically? So we've done it numerically in the table. We've found limits graphically from a graph, obviously. So how do you find limits algebraically? That looks like I spelled it weird, but anyway. You always start by plugging in the number. So we talked about that last time with the properties of limits. If your function is continuous, you just plug in the number, you're done. But when you plug in the number, so as x goes to 2, you're going to plug in 2. When you do that, three things can happen. So first is you get a number, which is what we saw last time. All of your functions gave you an actual number, I think. Hopefully on the homework they did. And so if that happens, you're done. You don't have to do anything else. Second case is you get a number over 0. For now, we're going to say does not exist for that. We're going to address that later in section 5 of this unit, but for now we're going to say does not exist. If you get 2 over 0, doesn't exist. If you get 0 over 0, that is not does not exist. Do not put does not exist. It tells you the function needs simplifying. So if you get 0 over 0, that is not a does not exist. That is a you need to simplify the function. So how do you simplify it? You can factor and cancel. You can multiply by a conjugate. You can get a common denominator and you can multiply it out. We're going to do an example of the first three. This theorem tells us why we can do that. So if f of x equals g of x for all x not equal to a, so for any x value that's not a, if the two functions are equal, then the limits are equal, the limits of the two functions are equal at a. So that should make sense if you think about the fact that the limit is what's happening around the point, not at the point. So even if they are not equal at a, their limits are equal. And actually this explains why we can do what we're going to do with these. So I'm going to jump right into the first example and I'll come back and talk about that theorem a little bit after we do that. So first thing we want to do is plug in 3. For the most part on your homework, you could actually skip plugging in 3. But if this was just a random limit like on your test, I would start by plugging in 3, or at least mentally do it. So plug in 3, you get 3 minus 3, which is 0. 9 minus 9 is 0. Okay, so this is not does not exist, and in fact you probably shouldn't even say equal to 0 over 0 because that's not what it's going to be equal to. Now, the notation is very important. The communication is everything, okay? For the AP exam, communication is everything. For regular calculus, I'm a little more lenient with this, but for the AP exam, communication is everything. So you need to have the limit notation there every time. I know people are like, why do we have to write that every time? You have to. All right, so we want to, obviously this one is a factor and cancel because we can factor the denominator. If you have a rational function, a polynomial on top, polynomial on the bottom, you want to factor and cancel. So our denominator is the difference of squares, factors to x minus 3, x plus 3. In the top, we want this to cancel with the denominator. We almost have it as 3 minus x instead of x minus 3. So we can switch it around by factoring out a negative. All right, so if the numerator or if one of your factors is in the wrong order, just pull out a negative and then you can have it in the right order. So now we can cancel this, which is what we want. You always want, no matter what technique you use, you want something to cancel. Okay, that's what your goal is. And once we get something to cancel, so I'm just rewriting what the new function is, then I can plug in 3 and I get negative 1 over 6 when I do that. So that is what our answer is. You're going to try one of these, so that's going to be on Nearpod. You're going to have to answer that. One quick thing, this function, this negative 1 over x plus 3 and our original function are the same function except at x equals 3. If you graph them, they'll probably look exactly the same. But at x equals 3, this one has a hole and this one doesn't. Okay, so that's the difference between the two functions. So that's why the theorem applies. That's why the theorem is in this section. All right, the next one, when you have a square root, you are always going to multiply by the conjugate. And sometimes if you don't have anything added or subtracted out here, you're going to multiply by the root itself. All right, the conjugate is the same thing. So whether the root is in the numerator or the denominator, it could be in the denominator. You're going to multiply by the conjugate. The conjugate is the same part as the root, same root, same 5, but is the opposite sign in the middle. and you're going to multiply by it on top and bottom. You have to do the same thing on the top as on the bottom to keep it equal. All right, it's algebra. You got to do the same thing top and bottom. The reason why we multiply by the conjugate is because when you multiply by the conjugate, here, I'm going to do a simple one off to the side because I don't want to show all the algebra. Let's say we multiply this by its conjugate. All right, we're multiplying conjugates here. If you FOIL that out, you get the square root of x squared. Square root of x times the square root of x is square root of x squared. 2 times the square root of x is 2 square root of x. Negative 2 square root of x is negative 2 square root of x. And negative 2 times 2 is negative 4. My middle terms cancel because this is essentially a difference of squares. All right, so your middle terms are always going to cancel. Square root of x squared is x, and then you have minus 4. So what happens is when you FOIL it, your middle terms are always going to cancel, and it's just equal to the first terms multiplied and the second terms multiplied. So we're going to take a shortcut. We're not actually going to FOIL the top. We're just going to do kind of the shortcut. We're going to say, okay, I'm going to multiply my first terms. Square root of x plus 20 times the square root of x plus 20 is just going to be x plus 20. And then negative 5 times positive 5 is negative 25. I already know the middle terms are going to cancel because that's what happens anytime you multiply by the conjugate. In the denominator, do not multiply this out. All right, don't multiply it out because you want something to cancel. All right, again, you need to write the limit every time until you plug the number in. So we are not plugging in the number here. We're still simplifying. We haven't gotten something to cancel yet, so we can't plug in the number. If you plug in the number, you're still going to get 0. Oops, this should be a plus. You're still going to get 0 over 0. So now we can have something to cancel. I'm going to go ahead and plug in the 3 now. I'm not going to rewrite it. So I get 1. When you cancel, you get a 1. I get 1 over, and then if I plug in 3, oh, I changed the 5 to a 3. I was like, why is it 3? Then if I plug in 5, I get the square root of 25 plus 5, or 1/10. I guess I was going back up to this one with the 3. So here's another one for you to try. So answer that one on Nearpod. And then the last one that we're going to do is common denominator. So this one requires the most algebra. My first step on this, there's a lot of different things that you can do with this one, but my first step is to get rid of this extra fraction thing going on. All right, basically what happens is you can just put the x in both of these denominators, but I'll show you why. To get rid of the x, we're going to multiply down here by 1 over x, and if I multiply down there by it, I have to multiply the top by it as well, and in fact the whole top. So these cancel, which is what we want. And then I'm going to distribute that 1 over x through. So that's how you can handle that. All right, then we want to get a common denominator. So if we look at our denominators right now, we have an x in both of them, right? We have a 5 in this one and an x plus 5 in this one. So I need to multiply this one by 5 over 5, and I need to multiply this one by x plus 5 over x plus 5. All right, so I'm going to do, the limit as x goes to 0 of 5 over 5x times x plus 5. And then I'm going to have x plus 5 in this numerator and 5x times x plus 5. Now I don't want to plug in 0 yet. Remember, we don't want to plug the number, I should have started by plugging in 0. It was 1/5 minus 1/5 over 0, so 0 over 0. Same here. If you plug in 5, this would be the square root of 25, 5, minus 5, 0, over 5 minus 5, which is 0. So this would have been 0 over 0, and this one also would have been 0 over 0. Sorry. All of the ones on the homework, there may be one that doesn't come out to be 0 over 0, but they all should because they're having to practice these techniques. But anyway, combine the fractions. We have to distribute the negative when we do that. Be careful with that minus. You do need to distribute the negative. So we get that as a single fraction. I usually try to avoid writing equal signs just because There's something in the grading called a linkage error if you say two things are equal and they actually aren't. So I usually avoid writing those for that reason, but sometimes I'll throw them in there. Okay, so our 5's cancel. We just get negative x over this. Now we're ready to cancel something finally. We have an, oops, just the x, not the 5. So this becomes the limit as x goes to 0 of negative 1 over 5 times x plus 5. And now we're ready, since we've canceled, we're ready to go ahead and plug in 0. So if we plug in 0, we get negative 1 over 5 times 5, or negative 1 over 25. All right, so that was the most algebra heavy part of this. A lot of people, when they get to calculus, they say, oh, I can't do calculus, but it's actually that you can't do algebra. It's not so much that you can't do calculus, it's that you don't remember how to do algebra. So here's the one that you're going to try on your Nearpod again. And, you know, just try it. If you get stuck in the algebra, you get stuck in the algebra, and we'll go over it in class. But just try it.